Hello.
Good evening.
How are you doing?
I'm okay. Quick question. On my assignment, my Excel assignment, you said I did not put the median, mean, and mode. Is that just because I didn't label the cells?
Yeah, that's what it means. That's what it means.
Okay.
So that one can know which is the mean, which of them is the median, and which of them is the mode.
Okay. I thought we just had to make sure that the
Your work are correct.
Huh?
Yeah, your work is correct. It's just the label, because when you do it that way, nobody will know which one is the mean. I know that the mean, median, and mode, but you have to put it so that shows a kind of a mastery, you know.
Okay, no problem. Thank you.
But the work generally, the calculations you did they are fine.
Right. I think I was more concerned of making sure that when you clicked on each cell that you could see the correct formula.
Yeah, that one is you did that. You did well. You did well there. They are good.
Okay, thank you.
You're welcome. You just the label and so so make it show the mastery of the. This is the mean. This is the median. Like if I'm not the person that gave you the assignment, I wouldn't know which one that you did. Yeah, as the mean, unless I have to go individually and check them. You know what I mean?
True. Yes.
Yeah. So today, we're working on we round up the confidence interval lecture by discussing the confidence interval for the proportions. So you can see my screen?
Yeah, unfortunately, that means I have to learn.
Well, you used the unfortunately the wrong way.
Go ahead.
All right, so now of course you guys know what a proportion is. We say a proportion, we are referring to a part of something, a part of something. So for example, I wrote here that the US Today Snapshot feature stated that 12% of the pleasure boats in America were named Serenity. So this 12% is a part of all the pleasure boats, a section of all the pleasure boats in US. There are a lot of US have a lot of pleasure boats. People can buy, as a matter of fact, one can buy a boat the same way you buy a car. Am I right? I know it's expensive.
I don't know. I don't own a boat.
But you can own a boat if you want. Huh? It's true. It's the same way you pay for a car. That's how you pay for a boat. I don't own a boat either, but I'm just saying, a lot of people see in my neighborhood. There's this part of it that is close to this and I think they call it Back River Neck from the Chesapeake Bay. People that live around the whole at the waterfront, most of them own boats, and they are not millionaires. They're just regular people like us. You buy it, you pay.
Who know how to drive a boat?
Yeah, who know how to drive a boat? Come on, Miss.
You need a license.
Sister. Huh?
Do they need license?
Yeah, you can get a license just the way you get the license.
I don't want to buy a boat. I want to buy a whole cruise, a whole yacht.
Yacht.
Yes, I want a yacht.
That's a millionaire talking there.
Of course, I have to be a millionaire.
When you buy a yacht, invite me for a ride. No problem. No charge.
Maybe. We'll see. If you give me an A.
Oh, I'm so sorry. It doesn't work that way.
Well, other way around.
All right, let's start. So anyway, what I'm trying to say here is that 12% is the part of all the pleasure boats, in US. So that's when we say we use numbers like that, we're referring to the proportion. Now look at the key terms we use when we are writing the confidence interval for the proportion. P represents the population proportion. This is the one we are trying to estimate, this P. Nobody knows exactly what it is. Only Providence knows that. But we try to estimate it as much as possible as we can. Just like we try to estimate the population mean yesterday and day before yesterday. So now we use this part, we call it p hat. So you see that it has a small hat on top of it. Well, I call it p hat. Or I can call it p cap, because you can have a small hat. Now, that represents the sample proportion. So that's what we're gonna use using this sample proportion to estimate the population proportion. Now, then how do we get p hats? We use, sometimes the question will give us the p hat, like here. This one is for the population, but some questions will give us the p hat in percent. Some will not. So that means we're gonna estimate it by using the x over n, the part of the proportion of the object of the part of something to give us, then divided by the total to get a p hat. Then Q hat is 1 minus p hat. Now then, of course, like before, you have to estimate the error using this formula. Once we have all of this, we can now estimate the confidence interval for the proportion using this formula. I will take you to the other workbook so I can get a character for p hat. It's gonna be in this form: p hat minus error. You got our p hat. Okay, p hat minus error. The less than p, which is what you're trying to estimate, then less than p hat plus error. Okay, p hat plus error. Plus error. So we add error on one side, on the right side, when we subtract it on the left side, and we get our p hat, and our estimate of the population proportion. Okay, which is right here. So let's start with an example. Example here says, in a random sample, of, make it a little bit bigger, make it something bigger. Okay, in a random sample of 200 investment advisors, 70 recommended information technology IT stocks. Give a 95% confidence interval for a true proportion. Okay, 95% confidence interval for the true proportion. Okay. All right, let's see. Let's do it. Ready? Solution. So it says P hat. Well, let's say X will be, let's say in a random sample of 200 investment advisors, 70 recommended technology stocks. So let us find the okay, it's made a proportion. So 70 is for X is 70. So we have N is 200. Okay, because it says out of 200, 70 recommended IT stocks. Okay, now let's find our p hats. I'm gonna write these things down so we can find our p hats. So the p hat will be X over N. Okay, p hat to be X over N. I will take you to the other workbook. So we have p hat equals X over N, X over N, which is S for N is, I will have, our S is 70, and our N is 200. This we can place in decimals. Calculator. Let's find this in calculator. So I go to calculator. Okay, share this. So I'll type decimals.com scientific. 70 over 70 over 200. So I got 70 by 200. Give me 0.35. See? So I'm taking it back to 0.35. 0.35, which I can copy. Okay. And paste it here. Get what I want. So P hat is 0.35. Now Q hat, see what is 1 minus P hat. Okay. Now Q hat. Okay. Q hat equals 1 minus P hat.
So what does the Q hat represent?
Opposite of P hat. If I say that 10%, let's say if I say 10%, that means the opposite is 90%. So let's say that I say that I'm 95% confident, for example. The opposite would be, let me say that my proportion, the proportion is that 80% of these advisors recommended IT stocks. That means if 80% recommended them, that's the P hat, then Q hat would be 20% that did not recommend that. Got it?
Yeah.
So that means 1 minus 0.35, which is we can get from our table. I'm sorry, our calculator. 1 minus 0.35. 1 minus 0.35. Give me 0.65. Okay, 0.65. 0.65. So I'm gonna copy this and put it in our main workbook. Okay, have it in our main workbook. Okay. Now we have our, so now next thing is to find the error margin. Remember the error margin, the formula is right here. For this one is a different formula. It's gonna be my system froze. Okay, let's see. My computer froze. Okay, I got it now. Let me copy it again. So this is the formula right here for the error margin. Z alpha over 2 times square root of P hat times Q hat over N. Now Z alpha over 2 we can get from table of normal distribution. Z alpha over 2. We got that from, I'll show you, it means the critical value. Alpha over 2 equals, from the table of normal distribution, for 95%. If you remember, I explained this yesterday. 95% confidence interval. Let's look at the table. You can either calculate it by yourself by using P over 200, or if it is given, like this one is given on a table. What you're gonna do is to go to that table that I showed you. You can see right here, I've seen some levels of confidence and their corresponding critical values. So for 95% here, so if you cannot see it, see for 95% is 1.96. So that the alpha over 2 is 1.96. 1.96. So you can plug in all these numbers into this formula to get the error margin. So taking you to our main workbook, we have that the error margin is, oh, before I do that, let me copy all these numbers out so I can easily put them in without coming back here. So I get P hat is 0.35, Q hat is 0.65, Z alpha over 2 is 1.96. Of course, N is sample size of 200. So we have this. Going back there, we have okay, error E equals Z alpha over 2. I can just copy this thing and put it here. Let me just copy it from there. Okay, I think I have already copied it. I can just paste it here. Okay. Error margin will be, okay, I copied it already, so I'm just gonna put it here. Okay. Equals, okay, I mean, equals, I don't know why it does this, but I'm gonna figure this out. So. Equal, okay. The alpha over 2, we get that as 1.96 times equation editor. Square root of, okay. Square root of P hat, which is 0.35, times Q hat, which is 0.65 over N. Our N is 200. Equals, now this is, we're gonna write this on the calculator to get it. So 1.96 times square root of 0.35 times 0.65 over 200. So let me take you to the calculator so we can get this out right away. So we have our Desmos calculator right here. So clear this, 1.96 times square root of, okay, I got 0.35 times 0.65 over 200. That 0.066104. So I just stop at 0.066. It's 0.066. So we got it 0.066. Okay. 0.066. So I'm gonna make it put it in our error into our main workbook. What's our main workbook right here? That's our main workbook right there. So once we have this error, we're almost done. Now we can get the 95% confidence interval. So this is the formula for that. So that's the 95% confidence interval is given by this formula, S bar minus error, sorry, P hat minus error, less than P hat plus. That means P hat, our P hat is 0.35 minus error of 0.066 less than P say less than P, okay, less than, and that's the other side, 0.35 plus the error of 0.066. So that means, let me just write 0.35 plus 0.066. So let's do the two of them from the calculator. So we have here we have that the 0.35 minus 0.066, give me 0.284, 0.284, and if you we put it there, 0.284 for the left side, 0.284. Less than the proportion. That means the one we are trying to estimate. Less than. Then we do this part. This one, 0.35 plus 0.066. So taking it back to the calculator, 0.35. Sorry. Yeah, 0.35. So you just make it, change it to plus. 0.416. 0.416. On the right side, 0.416. So 0.416. So that means basically what I'm trying to say here is that about 28.4%, it goes from 0.284, which is 28.4%. So I can even write it this way. I can write it like this. I write it like this as 28.4%, 0.4% to 41.6%. Okay. I can even write that both ways are correct. So, and some books might say it is, 0.284. Some books might write it this way, comma, 0.416. That's another way of writing it. So conclusion. If you look at this, the original question, it says, in a random sample of 200 investment advisors, 70 recommended information stocks give 95% confidence interval for the true proportion. So based on that, we can conclude we are 95% confident that between 28.4% to 41.6% of all investment advisors recommended IT stocks. So this is the answer right here, or that, or that. So that leads to this conclusion. Any question to this? Any question?
No questions.
No
Very
question.
good. Very good. Now this is basically what it is when we say confidence interval for proportion. But sometimes they might not give you the question in this form. If I give you in that form, let's say here, you say look at this. Okay, let's say if I give it in this form, it said a sample of 500 nursing students application included 60 from men. but no, not this one. Sorry, that's this one. Look at this one. It says a survey of 200,000 boats owners found that 12% of the pleasure boats were named Serenity. So they didn't give you like they didn't say out of 500 or something like out of 500 or incidents, 60 from men. Instead, they gave you the proportion as the p hat as 12%. So they gave you the p hat already. So now it says to estimate the p using that information. In that case, what you're gonna do is the same steps, except that there's some part of the work that you skip since you have p hat already. Solution have p hats. So I'm gonna take you to the order of the book so that we can get p hats. The p hats, okay. The p hat is 12%. P hat is 12%. Excuse me. 12%, which is 0.12. Okay. I'm gonna copy this and put it in our main workbook. That's our p hat there, right there. Okay. Now Q hat will be 1 minus 12%. So in that case, have Q hat, taking you to the other workbook. Q hat will be Q hat equals, okay, 1 minus p hat, which is 1 minus 0.12. I can get this from the calculator. 1 minus 0.12. So I'm gonna have 1 minus 0.12, 0.88. So you have it's here 0.88. 0.88. So I'm gonna copy this and put it into our main workbook. So it's gonna be here. 1 minus 0.88. That's our Q hat. Now we can then get the rest of them. Let's get the error margin. It says with 95% confidence. Suppose I make this 90% confidence. Suppose I make this with 90% or 99% confidence, or even 90, whichever one you want. So, so in that case, our Z alpha over 2, Z alpha over 2, alpha over 2, that's the critical value, equals for 99%, for 98, for 90% confidence, we go to the table where they are listed. If they're not listed there, you calculate it by yourself by using 90 over 200 and finding the value from the table of normal distribution. So for 90, you have 1.645, 1.645, 1.645. Okay. 1.645. Now, some books will say 1.65. It's still the same, just a rounding difference. So that our error margin will now become, remember the formula for it. Formula is Z alpha over 2 times square root of p hat times q alpha over n. So I'm going to copy this so that make it easy for us. So I'm going to paste it in the other workbook and make these necessary changes to get us what we want. Okay, I'm going to paste it here. So I'm going to, which is 1.645, I believe. 645 times, oh, I forgot. Let me get down the values for p hat and q hat. So I can just plug them in. So we got p hat is 0.12, q hat is 0.88, and our n, they give us the n as you say, out of 200,000. So 200,000. So n sample size. So n is 200,000. So now we have all the what we need. So I can go that m is 200,000. So let's go back to our other workbook so I can put all this information in. So we got p hat is 0.12 times q hat, which is 0.88 over 200,000. Let's get this on the calculator, see what the calculator will give us. So I got 1.645 times square root of 0.12 times 0.88 over 200,000. Okay. Now let's put it in the calculator. This most calculator. So I got 1.645 times the square root of 0.12 times 0.88, okay, divided by 200,000. It was 0.0001. That's it. That's very tiny. I got 0. Went all the way a long number of digits, but we're gonna stop at the third digits. 0.001. 01. So I'm gonna go and put it in 0.001. Okay, in the other book, 0.001, which I can now copy and paste it into give me 1 minute. 1 minute. Right, let's see. Paste it here in a main workbook. Okay, that gives us error of 0.001, so that the 90% confidence interval becomes just like before, p hat minus error. So I'm gonna copy that from the formula here. P hat, okay, minus error on the left side and p hat plus error on the right side, which is p hat is 0.12, 0.12 minus the error of 0.001 is less than p. Okay, is less than the proportion of or percent of the population, less than 0.12 plus 0.001. Okay, so I'm gonna make it a little bit bigger because it's small, too tiny. So, which means we can get that from the calculator. One side, 0.12 minus 0.001 equals, I will show you on the calculator right away. Have 0.12, clear 0.12 minus 0.001 is 0.119 to 0.119. Then if you add it on the other side, put plus sign. So let's say, let me write this one first, 0.112. For this side, we have 0.112. Actually, 0.119. Less than P. We're trying to estimate less than. On this side, we have, if you add these two, 0.12 plus, it's going to give you 0.121 to add them, which can be confirmed by putting a plus here. Put plus 0.121, okay, 0.121. Now, this is like saying 11.9% to 12.1%. Conclusion, some books might write it in this way, 0.119, comma, 0.121. Some books might write it this way. It's still the same thing. Conclusion. Look at the equation again. It says, find 90% confidence interval of the true proportion of the boats named Serenity. So between we are 90% confidence that between 11.9% to 12.1% of the boats named Serenity. Boats named Serenity. Well, we are 90% confident that between 19.11.9% to 12.1% of the boats are named Serenity. Questions? Any question for me?
No question.
Good. So next thing we'll be doing now is to see how to calculate the minimum sample size for proportion. If you're working with proportion, how do you estimate the minimum sample size you're going to use for your study? So for the proportion, we use this formula. Sample size n is p hat times q hat times z alpha over 2 over error squared. A good example of where this can be used is here. It says a researcher wishes to estimate with 95% confidence the true proportion of people who owns home computers. A previous study showed that 40% of those interviewed had a computer at home. Now it says the researcher wishes to be accurate within 2%. That means if you're going to be a mistake, it will affect only 2% of the population. Yeah, so if you're going to be a mistake, like a miscount, you're going to affect only 2% of the proportion. So find the minimum sample size necessary. Solution. You have our guess our p hat is given as 40%. So p hat, yeah. P hat equals 40%, which is 0.04. So 0.40, I mean to say. So I will have it here, p hat. Okay, which is 40%. Okay. And q hat will be 1 minus p hat. So q hat will be 1 minus p hat, 1 minus 40. Q hat equals 1 minus P hat. Okay. P hat. Excuse me. I have P hat, which is 1 minus 0.4. That gives us 0.6. Okay, you can verify this in your calculator. So I'm gonna put this in the memo book. Okay. Now, Z alpha over 2 this is for 95% confidence. So Z alpha over 2 will be Z alpha over 2 equals from the tables. Okay, and put it right here. See alpha over 2 from the tables. Get this. We say 95% confidence. So from the tables, this will give us go here. That is for alpha 95 is 1.96. So we go back and put it in 1.96. 1.26. Now, our error is given as well. Error, it says there is such a wishes to be accurate within 2% of the group of proportion. That means 2% is the error margin, which is 0.02. So we plug all this into this, information into this formula here, and we get our sample size. So the sample size is given by, so the sample size, the minimum sample size, okay, is given by the formula in, and then let's write these things down and go in and put it. P hat is 0.4. Q hat is 0.6. Error is 0.02. Right. Then Z alpha over 2 is 1.96. Let's go and plug this in the memo book. Sorry, other book. Then transfer it back to the memo book. Right here. So which give us equals P hat, which is 0.4 times Q hat is 0.6. Okay, times in parentheses. Okay, we're gonna put this. Okay, I'm gonna put that so that we have this in this form. Formula says the alphabet, which I have at 1.96 over error, right? 0.02 squared. On which we can put this into the calculator and get our answer as we got 0.4 times 0.6 times 1.96 over error square. Now let's put it in the formula in the calculator. We have so 0.4. Sorry, I need to say 0.40. Make sure you can see this. Yep, you can see it. 0.40 times 0.60. Okay, times parenthesis. We got 1.96 divided by 0.02. Okay, close it and square it. 23,2304. 2304.96. Okay, 2304. 0.96. 2304.96. So which basically is 2305 samples is needed. Okay, put in the memo book. That gives us this. We need 2304. That means the researcher will need, because this is a researcher, okay. The researcher will need, remember I could always run to the whole number, the next number. 2305 samples. Question?
Nope.
So the only difference, one more thing I want to mention is that if the proportion is not given, then you calculate it by yourself using the numbers, the values that are given. Like for example, here, it is not they gave one here. Now they didn't give any proportion here. See, the same researcher wishes to estimate the proportion of executives who own a car phone. She wants to be 90. So in this case, they didn't give you the P. But that way, in that case, use P hat as 0.5 and also use Q hat. Use P hat as 0.5, P hat as 0.5, and use Q hat as 0.5. That will give you the best estimate if they didn't give you P. Sometimes they might not give you P, they will give you the numbers 210 out of 300. In that case, you use this to estimate your P. And you then use a P as 210 divided by 300. Whatever answer I give you, then you can then use it to do the same process we just did here. But we didn't give you any proportion at all, then assume that the P is 0.5 and Q is 0.5. And that will give you the result that we have here. That concludes our lecture today. Any question before I check your attendance? Any query? Any question, objection? Any question?
No, sir.
In that case, I'll call your names and then we can go for the day and I'll see you next week. Okay, this is
Okay.
8, 4. So I got these people here. Can you mute yourself so they can hear their names? I got Tiffany Walker.
Here. See you.
Next week. Dolly.
I'm here.
Dolly's here. Okay, good. And I got Keshana.
I'm here.
Yeah,
I can't hear.
got all of you here. What happened to Vista? Vista, you still here?
I'm right here. Yeah. I'm always here.
Looks like me too. I'm here.
And Dijon Dunson.
Johnson. Wait, Dijon Johnson, what's your name? Your name is not showing here.
Oh, it says,
are you the TMO phone?
yes, I don't know
Oh.
why. I
Dijon
changed
Johnson.
it and then it changed back to it. I don't know what's going on with it.
Yeah, that's some of this technology. That's how they do sometimes.
Okay.
You
Well,
notice
have
that
a good day. You have a good day, Professor. Have a good rest.
Monday.
Alright. And
Same.
if I have to email you, could you please reply to it?
I will always reply your email. I mean, sometimes I miss it, but if I see it, I reply as soon as I see it.
Do you have like a phone number we can contact you on?
Yeah, I think it's on my syllabus, is it not?
I looked for it. I couldn't find it.
I'm gonna email it to you. Okay.
Okay. All right. You have a good day.
You too.
All right. Bye, y'all.
That Miss Rita, you here?
I'm here. Don't forget me, Professor.
You sure you're here?
I'm the Professor. Now make sure all
I hear you. I hear you. No problem.
I'm making a book too of all these samples, so make sure that's gonna be on the recording.
Oh yeah, they'll be on the recording.
Okay, all right, y'all have a good day.
You too.
Good weekend, be safe.
Yeah, we will.
All right.
Takia, Docket, you here? Takia.
Yeah, I'm here.
Taiji Kent. Taiji Kent, you here? And say, okay. Debbie, I have Debbie. So I got
I'm
Vanessa.
here. Darby's here.
Okay, see you Monday then. Vanessa, I got Vanessa here.
I'm here. I didn't understand a single thing you did today, but I'm gonna
happened?
review it. I'm
What
so
happened?
far behind in my lessons, but I'm gonna try to catch up.
Okay, I'm gonna if this record properly, I will put it on in Canvas so you can watch it again.
Okay. Thank you, sir. Have a good weekend, Dr. Otis.
You too. I guess that's the people here. I don't see Kyle. All right. Okay. See you guys Monday.